Okay. All right. My pre-cal's Math 1730s. This is the part 2 on graphing sinusoidal functions. So a lot of times we'll get stuff on the inside of the trig function, and it's tough to kind of see where the graph ends up. Okay, it's kind of hard to come up with a sketch for it. So if I gave you something like this, where I gave you y equals sine of 4x minus pi, and I say sketch one cycle, and what you're going to do is you're going to look on your screen, and you're going to see something, like this from between 0 and 2 pi, and it's going to be kind of hard to know where those exact locations are. Okay. However, I know that one cycle for sine looks like this. Okay? It's a hill and a valley. If I can figure out where this start point is and where the end point is, then I can draw it myself. And it's basically like what we're going to do is copy and paste that picture. So if I can figure out where is the new start, what's that location? Where's the new end? Then I can go and draw my picture in those spots, and then from then on, it's just copy and paste to get the entire wave. So that's really the point of today's lesson, is how do I figure out where this new start and new end is going to be for this graph, for say the sine of, I have 4x minus pi there, and how can I then apply that to sine graphs and cosine graphs. The technical name for that is phase shift. Okay, it's horizontal shift, but it's phase shift. So I'm going to start with something easier. I want to start with, say, our basic parabola. And if you look at three very simple points that this parabola has, right, it has -1, 1, 0, 0, and 1, 1. And from there, we can get the graph. I'm going to give you a transformation of this. So a transformation of this graph is x minus 2 quantity squared. And I'd like to be able to show that graph. How could I show that graph? And I'm going to track the movement of these 3 points. I'm going to show you how I know where they end up. So how can I figure out where these 3 points end up on this new picture over here? And here's what I'm going to do. Notice, in order to get these 3 outputs, I had to do -1 squared, I had to do 0 squared, and we had to do 1 squared. And that's how we got the outputs, which gives us our y, which gave us our coordinate. So what I want to do is I want to see what has to happen here so that I get -1 squared again. So what do I have to do here to get -1 squared? What do I have to plug in here to get 0 squared? And what do I have to plug in to get 1 squared? So essentially, I'm going to look at the 3 starting x's I had. I had -1, 0, and 1. I'm going to take my x minus 2, which is the inside, and I'm going to set it equal to -1. This was the old start. Okay, that's where the old picture kind of, for me, that's if I have that point, that's the far left point. So I'm going to pretend like this is my cycle here. And then I'm going to set x minus 2 equal to 1, and that was the old end. And then I'm going to set x minus 2 equal to 0, because that was the old middle. And if I solve all 3 of these, so all I did is I take the inside of my function, set it equal to what those original x values were, and if I solve for x, that's going to then tell me where my new x values will be, where those points have moved. So if I solve each one of these by adding 2, what do I get? I get x is 1, I get x is 2, and we get, here if we add 2, I get x equals 3. So now this is the new start, the new middle, and the new end. Okay? So That means that this point that was at negative 1, 1 is now at 1, 1, right there. This point that was at 0, 0 is now at 2, 0. This point that is at 1, 1, now it's telling me that it's at 3, 1. And there's my 3 points, and there's my picture. Okay, so I'm going to apply this same concept to this graph here. Because if you go and graph this on your screen, it's going to look something like this. It's going to be very hard to kind of see where the one cycle is. You can graph it, you can look at it. I'm just trying to save time and not use the technology, but at your seat, I would ask that you graph this here, make sure you're in radian modes, you're going to see something like that. So it's going to be hard to sketch one cycle. Notice nothing with the amplitude because the coefficient is 1, so the amplitude is still 1, and I did not put a vertical shift. So now let's look at on the sinusoidal, on the sine function. Okay, so for the sine graph, the original start is at 0. Okay, so what I'm going to do is I'm going to take the inside, my 4x minus pi, I'm going to set that equal to 0. That was the old start, the original, right? And then I'm going to take the 4x minus pi and set it equal to 2 pi. That's the old end. Okay? And if I solve for x on both of these, so you solve each equation for x, if I solve this one for x, and I solve this one for x, I'll now get the new start of the cycle and the new end of the cycle. And I'm leaving out the middle because if I know the start and end, I can calculate the middle in my head, I think, pretty easily. If not, all I need to do is know where the start and end is, and then I can draw the picture. So we just go through the math. How would I solve for each of these? So I'm going to solve for x for both of these, and the math is going to be the same. I'm going to add pi to both sides. All right, I get 4x equals to pi. And then what would I do? I would divide by 4. And so I get x is pi over 4. Now that's where this wave, sine of 4x minus pi, that's where that one cycle starts. Right over here, if I add pi, I get 4x is 3 pi, divide by 4, x equals 3 pi over 4. So now all I'm going to do in order to sketch this, okay, is basically I'm going to just copy and paste pi over 4, 3 pi over 4, okay? And I'm going to take this picture and copy and paste it here because that's what this information has told me. Where does the new cycle start? Where does the new cycle end? I know that now. I know the peak and valley are 1 and -1. And I'm going to draw my little sine curve. And that's that. Okay? If I wanted the middle, you can see the middle is going to be 2 pi over 4, which is pi over 2. And then if I wanted to draw more cycles, I could keep drawing more cycles. I just add on another 2 pi over 4s, and I can draw the next cycle. So is that, and I get to go to 5 pi over 4, and I could draw the next one again. Okay? All right, but that's essentially what you're doing. You're trying to figure out where the new start and end for that cycle is by using this method. So whether it's a sine or a cosine graph, doesn't matter. My method is the same. So what's one cycle for sine? We know that one cycle goes from 0 to 2 pi, and it looks like this. And cosine goes from 0 to 2 pi, and it's basically like half a hill, a valley, the other half of a hill. So there are the pictures that I'm going to copy and paste. I'm going to take the inside and I'm going to always set it to 0, and I'm going to set it equal to 2 pi, and I'm going to solve for x to get the new start and end. Okay, so let's take another one here. Let's say we have, we'll call this one example 2. So let's say we have, I'll call this example 2, y equals 4 cosine of 8 pi x. You want to sketch one cycle. All right, so here's the first thing I'm going to do. I'm going to take care of the 4 right away. And look, you can use your, you can type this in, move over here. You can type this in on your calculator, but it's just going to be a mess to look at. It's going to be hard to kind of really see what's going on with the wave. So I'm showing you this as a real quick way to get a solid picture of one cycle. All right. So it's not like you can't use your technology to help you. You can just type it in, make sure you're in radian mode. But I want to also show you this. Okay. What does the 4 do? So we talked about the 4 last time. The 4, I know, is going to stretch it vertically. So I know that the peak and the valley now is going to look like this. So right now, that's just 4 cosine of x. I hope you agree with that. So I'm going to take care of the 4 first. I know the 4 is going to stretch it vertically. Now what do I do with the 8 pi x? I take the 8 pi x and I set it equal to 0, and I take the 8 pi x and I set it equal to 2 pi. Why 0 and 2 pi? Because that's where the original graph starts and ends, okay? So I'm going to solve for x. So you're going to say, well, how do I solve for x? Well, this is just multiplication. So divide by 8 pi, and I get x is 0. Divide this one by 8 pi, and you get x is 1/4. So what have we learned? We've learned that this graph, you can tell, think about it, is it going to get stretched or is it going to get smashed? Well, it originally goes from 0 to 6.28, because 2 pi is 6.28. Now it's going to go from 0 to 1/4. So it's getting really smashed, and that's because this number in here is larger than 1. It creates a horizontal shrink. So if I want to now graph it, I know 4 and -4 are the peak and valley, and I'll just put 1/4 there. I mean, I don't need to do anything else. And then draw my picture, and there you go. And there's my one cycle. Okay? All right, so notice I handle the vertical stretch first. Okay? I do that first, and then I handle the phase shift. Okay. So let's do one more, and hopefully these will be 3 good examples for you to work on. All right. All right. I always have to go back and know what my original graph is. So we'll call this one example 3. Say we get y equals -2 sine of 2x plus pi. Okay. Here you go. Okay, so the -2, what's that going to do? Well, you can draw it, right? But we know the original graph goes up to 1 and down to -1. And we go to 2 pi, right? All right. So the 2 would stretch it, and then negative is going to flip it. So if I deal with this first, I should get this picture. That is -2 sine x. Okay? And you can type it in and verify that. This was the last lesson. So we have to build off of the last lesson. All right, so that you should have this understanding from lesson 1. Now, what are we asking you to figure out in lesson 2? What happens here? 2 things happen to it. The plus, you know, it's going to move left. It's not going to move left pi. I know you think it's going to move left pi, but that 2 has an effect on it. The 2 smashes it, and then it moves left, okay? So we're going to know exactly how far left it goes and what's our new cycle going to be by going through the method that we talked about. We take the inside, the 2x plus pi, and we set it equal to 0, and we take 2x plus pi, and we set it equal to 2 pi. Why 0 and 2 pi? Because that was our original start and end. And once I solve for x, so subtract pi, 2x is negative pi, divide by 2, x is negative pi over 2. That's going to be the new start, okay? 0 was the old start, negative pi over 2 is the new start. Subtract pi, 2x equals to pi, divide by 2, x is pi over 2. That's going to be the new end. So I've got to draw this picture here from negative pi over 2 to pi over 2. You can put it on the same frame if you want. I'll try to draw this in the dark blue here. So this is pi, right? So that's going to be negative pi. So negative pi over 2 is here and pi over 2 is there. Negative pi over 2 to pi over 2. Now I've got to draw that picture in this frame here. So it's going to be like that, okay? You can just redraw the whole thing if you want. I'm going to now erase this. There we go, negative pi over 2 to pi over 2. And from this, if I review from last time, I should be able to find my amplitude. So my amplitude is in negative 2, it's 2. It's the absolute value of that number. And my period is 2 pi over the coefficient of x of over 2, which is pi, which makes sense. If I have a half pi to the left and a half pi to the right, I'm good there. All right, one more, because we'll do one that has everything now. Vertical stretch, horizontal phase shift, and then a vertical shift. We'll do all three, and I'll do those in that order. So we'll go back to cosine. Call this example 4, sketch one cycle. So let's say you got y equals 3 cosine 6x minus pi plus 1. Okay, so you got a little bit of everything. I'm going to look at what's my basic graph going to be. So since I see it's cosine, I know that one cycle for cosine is the U shape there. I'm going to go in this order on my transformations. I'll do this one first, the horizontal phase shift second, the vertical shift third. Okay, so what does a 3 in front do? Okay, yeah, stretches it by a factor of 3. So that's the first thing I'm going to do, is draw one cycle stretched there. There's that. So right now I have 3 cosine x. Okay, now what do I need to do? So second, now I'm going to take the inside, 6x minus pi, set it equal to the original start, 6x minus pi, set it equal to the original end. I'm going to solve for x, okay? All right, and when I isolate, I get 6x is pi, divide by 6, x is pi over 6. Over here, subtract pi. I'm going to leave it not simplified for a second. X is 3 pi, so x is 3 pi over 6. The reason I'm going to leave it not simplified is easier to see what a good incrementation would be. So since the start's pi over 6 and the end's 3 pi over 6, I'm going to use pi over 6 as the incrementation. So now I'm going to have to draw that picture in that boundary. Okay, so the analogy I like to use is copy and paste. I'm copying this picture, but I'm putting it in this window from pi over 6 to 3 pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6, and then we've got the 3 and the negative 3, and it's this. Notice I put the 2 ends in the middle, and I draw that. Okay, there's that. So right now I have y equals 3 cosine 6x minus pi. Notice it moved right, but it didn't move right pi. It only moved right pi over 6 because of this factor of 6 in there. Okay? So it smashes the graph and it shortens how far it moves. All right, what's the last thing? +1. So I gotta just move everything up 1. These two dots will move up to 4. This dot here will move up to -2. And there's my final picture. Unfortunately, you're not doing your work on a whiteboard. You can erase it, but there it is. So now I'm showing you basically how can I handle the bx minus c together in one problem, and this is the process for doing that, okay? So that ties everything together, and this is in a nutshell how you can graph one cycle of a sinusoidal function. That will be it for this section, and as I send you this video, I'll send you an assignment too, and hang in there, guys, and keep self-isolating and staying safe, okay? Talk to you later.